prior to the 1970s, many textbooks for grade 6 to grade 8 use or had many of these problems with infractions that just seemed impossible. 258 divided by or over 559. And, the question was, what do you do? Well, you would have probably started off by looking, are the numerator and denominators divisible by the usual suspect? Are they divisible by the prime numbers, 2, 3, 5, 11, 7, 11, right? So, and so on. Well, definitely not divisible by 2 because while the numerator is even, the denominator is not. If we check divisibility by 3, the numerator 2 plus 5 plus 8 gives me a sum of 15, so that seems promising. But when I look at the denominator, 5 plus 5 plus 9, that's 19, so it's not a multiple of 3. So 3 does not divide both numerator and denominator. Continuing, neither of these end with a 5 or 0, so that's no luck. If you tried, and I'm not going to do it, but if you tried, 7 will not divide it, nor will 11. So we begin to ask the question, how do we do this? Or how did the students from the 1970s and earlier, how did they do it? Because they didn't have calculators. And the idea was for them to be exposed to this thing called the Euclidean algorithm. Now, an algorithm is simply a group of steps that one uses to solve a given type of problem. So every type of algorithm or every type of problem, you have a bit of a different strategy. All right. So let's talk a little bit about this Euclidean algorithm. Now, what the Euclidean algorithm says is that you're going to take the numbers and you're going to divide the larger number. I don't care that it appeared on the denominator. Divide the larger number by the smaller. So we are looking at 559 divided by 228. Let's look what we would do or get here. So if I'm trying to do this division, 228, 559, we could look at our experience and say this is a 3-digit divisor. So let's round to the nearest 3 digits. 258, sorry. I'm glad I caught it there, 258. And so if I rounded these to the nearest hundreds, this would be 300 for the divisor and 600. So 300 into 600 would be 2, or 6 divided by 3. So this time we're getting rid of those 2 places, and we end up with 2. So I will put in a 2 here and ask now, what is 2 times? What is 258 times 2? 8 times 2 is 16, carry the 1. 5 2 is 10 and 1 11. Carry the 1, we have 516. We'll subtract and end up with 43 as a remainder. So far I could go back here and let's write 559 is 2 times 258 plus that remainder of 43. So Euclidean algorithm says continue. What you're going to do is the numbers, the divisor and that remainder, you're going to do the same process. You're going to divide them. So I'm going to write the 258 here. We want 43 times something, and we want to find out what numbers will I fill in here. So we keep going. This one will probably be a short one. So 43 into 258. And again, we go back and look at doing this by estimation. This would be roughly 260 divided by 40. So 26 tens divided by 4 tens. 6 fours, 24. And we'd write 6. What is 6 times? Let's even do that in a different color just to get it. So 6, I didn't get it there. 6 times 43. What do we get? 43 times 6. 6 threes, 18, carry 1. 6 fours, 24, and 1, 25. And lo and behold, we end up with 0. Now, the Euclidean algorithm said that you should have continued with doing all of this. That is, each time you have a divisor and a remainder, you keep switching them and keep carrying that division until you get a 0. Once you've done that, the answer that you're looking at, common factor, would be the line above, the remainder above, so 43. So what we're going to ask is what is 258 divided by 43, and what is 559 divided by 43. We're half done, luckily, because the numerator was 6 using what we have down here. However, let's continue with finding that divisor. And again, doing that divisor, 559 divided by 43, we would round this to the nearest tens. Or better still, let's do this long division way. So 559 divided by 43. All right, what do we do? 43 goes into 55. Well, that's pretty easy. Once. 1 times 43 is 43. And we are now left with 12. Bring down. So now 129 divided by 43. And whether you want to round this to the nearest tens, so 130 divided by 40, what is 13 divided by 4? 4 into 13 goes 3 times, so we're looking at writing 3 here. And then 43 times 3. 3 3s 9, 3 4s 12, so we subtract 129. 43 goes evenly into 559, the denominator 13. So our final answer, I know it's a little crowded, but I will put it all together. So our original question was, what is 258 as a fraction? 258 over 559 can be reduced to 6 over 13. There is a way when we do this division, it can be compacted. But let's look at another example a bit. All right, if you were given this question, again, this was pre-1970, which is not uncommon, you would have gotten 1,302, these huge numbers for both numerator and denominator. One of the things we could look at is, again, just as before, is it divisible by 2? And the answer is yes. Both of these, 1302 divided by 2, they were even. So we can do this division. So let's even do it over here. 1302, 2 into 13 goes 6 times. 6 times 2 is 12. Bring down. 2 into 10 is 5. And 5 times 2 is 10. We now bring down the 2. 2 into 2 goes 1. And 2 ones is 2. So I won't really color code anything here because it's one digit division, which should be pretty easy. All you have to do is pause the video and, try to work it out now that you know what steps. We're dividing 1,000, the denominator 1,488 by 2. 2 into 14 is 7. 7 2 is 14. We get 0. Bring down the next number. 2 into 8 goes 4 times. 4 times 2 is 8. Subtract. I get 0. And 2 into 8 is 4. 4 times 2 is 8. We subtract. And we get 0. So exactly 744. And we knew that this was divisible by 2. We can then check, is this resulting fraction? Can I divide it by my next prime number, 3? So let's check. The sum of the digits for the numerator is 12, so that's good. How about the denominator? 7 plus 4 is 11, plus 4 is 15. So yes, both of these, 651 divided by 3 and 744 divided by 3. Let's do that. So again, these are problems in which your rough work is much greater than your actual solution part. 3 into 744. All right, 3 into 6 goes 2 times. 2 threes is 6. We bring down the 5. 3 into 5 goes 1 time. Subtract. And 3 into 21 goes 7. 7 threes, 21. So our numerator is 217. Let's find out what our denominator is. 3 into 7 goes 2 times. 2 times 3 is 6. 3 into 14 goes 4 times. 4 threes, 12. And 3 into 24 goes 8. 8 threes, 24. So 248. All right, and now we begin to ask what goes into both of these. Our usual suspects of trying, can I divide by 5? Of course not, because neither of these ends in neither of them end in 5 or 0. 7, if you try, won't work. So let's now proceed from here and try the Euclidean algorithm. So the Euclidean algorithm says I'm going to take my smaller number as the divisor. So I'm actually turning the problem around a bit. If you look at this, it's 200 and something being divided by 200 and something. It only goes once. So I'll subtract. And we end up with 31. So we are seeing that 217 or 248 is 1 times 217 plus 31. All right, now going back, if you looked at what we did up here, we are taking our divisor and remainder, and we're pushing them over one set. So here are the numbers I'm dealing with. And what we want to do is we want to write 217 as something times 31, and so on. Right? If you were in the classroom back in those days, what would happen is, let me just say this, 217, you would have written it in this fashion. subtracted 217, you have 31. We would continue, and I'll color code it, and write back your divisor, your previous divisor, the 217, and 31 into that. How do we do this? Well, we would have 217 divided by 31. This is rounding it, approximately 220 divided by 30. 22 divided by 3 would give me 7. So I'm going to try 7. Let's carry out the product. 31 times 7, 717, 7 3 is 21. I would get 0. So it would then say that 31, previous remainder, is what you're going to divide each part by. So looking back at our fraction, 1,302, let me write it down here and then come back.